Today I'm going to show you how to build this line following robot. It uses basic components and there's no coding required, so it makes it a perfect project for beginners. The design is based off a book called Robot Building for Beginners by David Cook. It utilizes a pair of photoresistors which can detect a black line on a white background. When one of the photoresistors crosses the black line, this information is fed into a comparator. The comparator then shuts off the corresponding motor. This results in the robot correcting itself and centering back on the black line as it drives forward. The first thing I like to do when using a breadboard is get a red wire and connect the two red positive voltage buses that run along either side of the breadboard. I'll use a black wire to do the same thing with the ground voltage buses. This allows me to distribute the power from the 9-volt battery across the entire breadboard. I always like to put a little red LED on the power rails of the breadboard. Not only does this help me know when there's power applied to my circuit, but it also helps remind me to turn the power off when I'm not using it. Next, I'll put the two photoresistors into the circuit. We'll be creating what's called a voltage divider with these photoresistors. We'll create a left-hand and a right-hand voltage divider. Next, I'll connect this 100 ohm resistor to the 9-volt battery. This will supply power to our two voltage dividers. I'll need access to the output of the left-hand voltage divider on the right side of the breadboard, so I'm going to add this little orange jumper wire. Likewise, I'll need access to the output of the right-hand voltage divider on the left side of the breadboard, so I'll add another jumper wire. Alright, I look at this and I realize I made a mistake. The 100 ohm resistor needs to go between the two orange jumper wires. Now I can insert the 20 kilo ohm potentiometer. It's time to insert the LM393 dual comparator into the breadboard. This is the brains of the robot. It takes the information from both photoresistors and compares them to see if the robot has crossed the black line. The LM393 needs power, so I'll attach pin 4 to ground and pin 8 to 9 volts. As you may have guessed from the name, the LM393 dual comparator has two comparing circuits in it. I want to connect the output of the left-hand photoresistor to pins 5 and 2 of the LM393. This is where our two orange jumpers come in handy. I'll also want to connect the output of the right-hand photoresistor to pins 3 and 6 of the LM393. Logic components like the LM393 are great at making decisions based on their inputs. However, they're not usually designed to source or sink a lot of current like from a motor. That's why we're going to take the logical output of our LM393 and beef it up using a transistor. The transistor will do all the heavy lifting and supply the current for the motors instead of the LM393. The transistor needed for this circuit is a PNP transistor, so I'm going to use the 2N3906. Transistors have 3 pins on them: the emitter, the base, and the collector. I will put a 2N3906 on both the left and the right hand side of the breadboard. I want to drive these transistors in their saturation region so I can use them like a switch. To do that, I'll put a 1K resistor from pin 7 of the LM393 to the base pin of the transistor. Likewise, on the right hand side, I'll use a 1 kilo ohm resistor to connect pin 1 of the LM393 to the base pin of the right hand transistor. Next, I'll connect the emitter pins on both transistors to 9 volts. Now I'm going to attach a green LED to both outputs of the LM393. This will serve as an indicator telling us which photoresistor is receiving more light. Alright, it's finally time to test the circuit. Plug in your 9-volt battery and you should see one of the green LEDs come on. That means that photoresistor has more light. Go ahead and use your hand and cover up that photoresistor and you'll see that the opposite LED turns on. Now you can move your hand back and forth, and depending on which photoresistor has more light, that LED will turn on. I'm going to go ahead and turn the 9-volt battery off in preparation for connecting our motors. Before you get too excited and turn on your 9-volt battery, we got to remember that motors are an inductive load, which means that we have to use a flyback diode to protect our transistor from the large voltage spike that occurs when the motor shuts off. Without these diodes, you'll likely burn out the transistor on your first use. Trust me, I speak from experience. When I got to this point, I turned on the 9-volt battery and the motors kicked on. However, the right LED was glowing a bright yellow color. I panicked and I turned off the battery really quick. Upon closer inspection, I realized that I had connected one of the motor wires in series with the LED, which meant all of that motor current was being fed through the LED. I'm surprised it didn't explode. I took corrective action and tried again. Now it's time to build a body for the robot. I found this white sandwich container at my grocery store, and I used a black permanent marker to mark the position where the holes need to go for the motors. Next, I used a wooden base so that I could drill through the holes. I started out with a small bit and worked my way up to a bigger bit. Next, I took a hot glue gun and I glued the motors in place. It's time to put the breadboard into the sandwich container. I used a piece of blue tape to stick to the back of the breadboard and put it in position, making sure I left enough room for the 9-volt battery. The 2 photoresistors need to be facing the ground, so I used a screwdriver to start holes so that I could drill through them and place the 2 photoresistors through the holes. Then I used a pair of tweezers to put the photoresistors back in the circuit. And finally, I used a dab of hot glue to make sure they didn't move. Now I put the battery in and connect the motors up. And I slide the wheels on. And test it out. I noticed that the right wheel was going the wrong direction, so I swapped the 2 wires. I did some final testing here just to make sure everything was working right. Then I glued a plastic bottle cap in place to act as the front wheel. I used some black electrical tape on a white surface to make a circular course for the robot to drive on. I had a lot of fun building this project, and I hope that it inspires you to build something similar.